Good afternoon, everybody. Welcome to the Industry Studies Association's webinar on green industrial policy. My name is David Hart. I teach at the Schar School at George Mason University. And I am the co-organizer of this series along with Andrew Reamer of George Washington University. Industry Studies is a professional association of researchers who focus on specific industries or sectors as opposed to the economy as a whole or management as a whole or whatever the person's discipline is. We will do two more webinars in this series this spring on April 28th. We have one on federal agency industry studies units, and then on May 12th, federal industrial strategic plans. We also have one more session in our series on racial equity and opportunity that's being organized by other colleagues on the ISA board, and that's on April 7th, and it's called Addressing the Racial Wealth Gap. And then, of course, we have our flagship event, which is the annual Industry Studies Conference. This year will be held virtually June 3rd and 4th. We had a really good virtual conference last year, and it'll be even better this year. So hope you'll all join us for that. The theme of the conference is Work of the Future. So thanks again for joining us today. We have a great panel lined up, and I'll introduce them in just a moment. Each of them is going to offer opening presentations of about 15 minutes. Then we'll have around a half an hour for Q&A and moderated conversation, and you're welcome to put questions into the chat. And then for those who would like to join a smaller group, we'll have breakout rooms that go until 2 o'clock. So we'll wrap up the plenary session at around 1:15. With that, let me briefly introduce the topic. For those of you who are with us in our fall series, or who may simply be following the news, you'll recognize that the concept of industrial policy is on the rise. That is, policies intended to support the fortunes of a specific industry rather than industry as a whole, often in the context of global competition. In other words, the purpose is to give domestic production an edge. The idea of industrial policy is taken for granted in many places around the world, especially small countries that are dependent on trade. By the United States, it hasn't always been so. It was highly controversial in the 1980s, and that spawned a big literature that many of you are probably familiar with. There are a lot of reasons why it's gained currency recently, but one of the leading ones is that there's been concern about the environment and with climate change specifically. In order to deal with climate change, humanity is going to have to retool a lot of industries. We've already started on that in the power sector. The auto industry is coming soon, and beyond that are other industries like steel and chemicals, agriculture and construction. We may even need to create some new industries to pull carbon out of the air to compensate for emissions that are just too hard to abate. So as countries look forward into this transformed industrial landscape, they see not only risk, but also opportunity. And that's what green industrial policy seeks to realize, to try to gain a foothold in these massive new sectors that we are going to have to build if we're going to avoid the worst consequences of climate change. So with that as a backdrop, let me introduce the panel. We'll hear first from Henry Kelly, who's currently a senior fellow at Boston University's Institute for Sustainable Energy. He's been in academia the last few years, but for most of his career, he served in the federal government, at the Congressional Office of Technology Assessment, at the White House Office of Science and Technology Policy, and at the Department of Energy. And he also spent a number of years running the nonprofit group, the Federation of American Scientists. And full disclosure, he and I are collaborating on a research project on technology solutions for industrial greenhouse gas emissions. Then we'll hear from Alfred Marcus. Alfred holds the Spencer Endowed Chair in Strategy and Technological Leadership at the University of Minnesota's Carlson School of Management, and he is a longtime member of the Industry Studies Association. I'm not going to try to summarize his CV, which ranges very widely, but most recently, he is the author of Managing Strategic Uncertainty, Booms and Busts in the Energy Industry, which was published by Cambridge University Press in 2019. And the third speaker is Sarah Ladislaw. She's the Senior Vice President and Director of the Energy and National Security Program at CSIS. CSIS is a landmark Washington institution that focuses primarily on international affairs, and Sarah has been working for CSIS and helping run their program for more than a decade. She is a real pillar of the DC discussion around climate and clean energy, and her program produce great reports, which you'll hear something about today. And those of you who take an interest in this topic, you'll certainly want to follow her. With that, I'm going to stop sharing this screen, and I will turn it over to Henry to share his screen. So thanks again for joining us. please put your questions into the chat and look forward to the discussion.
All right, can you see what I've got up here?
Not yet.
Okay.
There we go.
Okay, got it.
Yep.
All right. Well, thank you, David. So in this talk, what I'm going to do is go from 50,000 feet down to some specifics and give you a broad overview of the history of federal intervention in innovation and what's happened as a consequence of climate change is that an entirely new dimension has been very salient in this discussion. And what's become obvious is that if you're actually going to meet the Paris goals, which you're going to have to be getting down to zero net emissions or even negative emissions in the next 30 years. And that requires dramatic transformations at all parts of the economy, certainly including the industrial economy. So I'm going to take a quick view of the broad landscape of federal R&D, zero in on the Department of Energy and explore how they're reacting to this challenge. And then just for interest here, there are three interesting new areas where I think industrial policy will be very relevant here in the next decade in meeting these challenges. But I'm sure, as you all know, that if you're really going to get a coherent approach to industrial policy, you need both to have R&D and innovation at the laboratory and at the demonstration level, pushing ideas out into the marketplace. But you definitely need to have a market for these technologies. And this is particularly important in energy because in many cases, the incumbent industries are enormous, they're conservative, and finding ways to deliver a different kind of product into those markets is incredibly difficult. And there are a variety of different tools, but it's pretty apparent that you need an integrated approach to be both pushing these technologies through innovation and R&D and pulling them out through the integrated, closely coordinated set of transformational market policies. And if you look at the history of US R&D, some very dramatic things have been happening. The most obvious is that the federal government's share has been declining rather dramatically. That huge bump, by the way, in the 60s was the Apollo program. But you see the industry and other, which are largely foundation or entrepreneurial driven investments, taking over the share. But of course, what's likely to happen in this kind of a trend is that industry, of course, is focusing much more on applied research, and the federal government, which has always been looked to for the basic research that's underpinning all innovation, has been declining. It's something that has been complained about for years, and we're hoping we can finally start doing something about it. It's clear that other countries have been doing something about it, and the US actually invests a larger share of the GNP in research than Europe. But as we'll see in a minute, that's largely because of our defense research. China is now ahead of Europe and growing fast, and it's really unique for a developing an intermediate income country to be investing so much in research. It's clear that they've made this a major priority. If you look at how the US invests its research and compare it to the OECD average, the differences are really very dramatic. You can see that we've invested much more in defense. Over half of our R&D is in defense. And we have a very large health-related investment. OECD invests a lot more in energy and the environment, in industrial technology, and in general science than we do. So this is puts us in an interesting position, potentially at a severe disadvantage. Now, if I turn specifically to the Department of Energy, of course, is not the only federal agency involved in innovation for the green industry, but it's certainly one of the major players. one of the things that's usually a shock to anybody coming into the Department of Energy is to discover that energy is only a small fraction of what the Department of Energy actually does. And I have, I have a friend who was actually in the room with Ronald Reagan who was discussing abolishing DOE, and he leaned over and said, "They have the bomb, you know." And the bomb is still about half the budget. He's spending almost $8 billion a year cleaning up the mess made by the, largely made by the weapons industry. You have a science program that's actually bigger than the National Science Foundation in some years. It's huge, $7 billion a year. And then you have the energy program. Interestingly enough, in spite of severe cuts proposed every year by the Trump administration, and by severe, I mean cutting by factors of 3, Congress has given very strong bipartisan support to maintaining the research priorities in energy. And in particular, it's been generous to energy efficiency and renewable energy, which has enjoyed striking growth in spite of the fact that the administration was trying to cut it by a factor of 3. So if you're going to try to say, how do you want to set priorities in trying to inject clean energy into this research portfolio? I mean, one way to look at this is to say, where are the greenhouse gases being produced in the energy sector? And you can see what I'm showing you here is where the fossil fuel, the greenhouse emitting gas emitting activities are taking place. So you can see here in the residential and commercial, these are the use of fossil fuels directly by these by buildings. So that's heating primarily, some hot water and cooking, but most building energy is electric, and we'll come to that in a minute. Industrial energy use is a whopping chunk here, 23%. A lot of it is in heavy industry, but a lot is spread through things like chemical production and pulp and paper and in other areas, including agriculture, because agriculture is included in industry by the Department of Energy accounts. Transportation, of course, is a huge fuel user, and electric is a major challenge. So one of the things we're trying to do, an obvious thing to do, is to try both to increase the efficiency and to replace this fuel use with electricity that's generated from clean sources. And if you look at where the electricity is generated, you can see that a significant chunk of electricity is already being generated by renewable or nuclear, the sort of low carbon energy production. So the strategy is to replace a lot of these other fossil fuel users with electrification or something equivalent, as well as increasing their efficiency. About 70% of the electricity generated, by the way, goes to buildings, residential and commercial buildings. So if you look at how we want to approach the challenge of making massive reductions in particularly the industrial sector, there are a variety of strategies that need to be pulled together, some traditional and some quite new. Obviously, one thing you want to do is to change the production process itself, shifting to electrification, which the steel industry has largely done. The clever use of optimization, digitization controls, possibly using hydrogen, looking at the use of biological processes to substitute for fossil fuel processes, and of course, capturing the carbon that's generated by these industrial processes. But also, there are a variety of other things that can be done. One of is to make much more efficient use of materials, which we can do with good design and good production techniques. New tools, new materials themselves. We've got some really interesting new computational materials design technologies that can produce much greater functionality at a much reduced weight and energy input. And of course, the circular economy, about 70% of all US steel right now is made by recovered steel from other processes. And there's a hope that this can be replicated in other sectors. Some are particularly hard, particularly concrete. So now I'm just going to toss out three wildcards of some interesting new things that have been happening that could driven largely by the need to meet climate goals, that could have a very interesting impact on American business and industry in the next few decades as we're trying to meet these climate goals. It deals with agriculture, mobility, and the potential use of hydrogen as an energy carrier. So let me start off with agriculture and do a very simple-minded calculation, which is that you have agriculture is, after all, a process for largely from converting sunlight into something useful. And so if you start off with 1 unit of solar energy, you grow plants, you feed a lot of these plants to cattle. You then convert the plants and the animals into some processed food. And at the end of the day, you get 0.1% efficiency. And I've probably been overestimating this. There is no industrial process that comes close to being inefficient. And I haven't even included all of the energy used in fertilizer and farm equipment and other things. So the question is, here is a chemical production technique that is the oldest known to humans. Is there a way to make this more efficient? And the answer is that there are a lot of really interesting new tools that are exploding into the venture capital world, where they're saying, hey, well, producing a protein is like producing any other chemical. We can use from the powerful tools of synthetic biology to make this a reality. And the cost of doing this is coming at least in theory, is coming down at a rate that looks like Moore's law. Second one has to do with mobility as a service. And that is the idea that you're not selling cars, or you're selling mobility. And here there are a lot of very interesting things that have been happening. As it was clear before the pandemic anyway, that service companies like Uber and Lyft were just blowing away taxi services. And people have begun to say, well, wait a minute, there are a lot of very interesting design dimensions here that we can start thinking about. We could be having different kinds of public transportation services. We can have different kinds of vehicles. We can have electrification, and eventually we may have automation. And to try to figure out how all of this shakes out, you really have to look at a large number of variables, including what we now see as a free good, which is the cost of people stuck in traffic, but parking, land use, and many other things. One of the biggest barriers to mobility as a service has always been the cost of drivers. But new computational technology can optimize these systems. And here my friend Pascal van Hinterrijk looks at the city of Atlanta, and that's what this is from. But it turns out that if you look at optimizing the way trips are scheduled, the size of vehicles, the number of people in each vehicle, you can make a huge impact. And calculation at MIT showed that you could provide the taxi service of existing New York City taxis with about 1/5 as many vehicles as you have in play right now. So the potential for reducing congestion is very large. And this is not just a theoretical possibility. The idea of using shared vehicles that will get people to mass transit corridors has become a core strategy for major cities like Boston. And Los Angeles just introduced a major service last month to use shared vehicles to get people to transit stops. And the first thing the final piece that I wanted to mention was hydrogen. We've been moving energy around in the form of natural gas and electricity. This is a new potential way of moving energy around. I should mention that all biological systems, including us, use hydrogen as the main energy source for going from ADP to ATP. But if you're going to make hydrogen in a commercial scale for the US, you've got several different options. You can split water, you can use standard natural gas techniques and sequester the carbon. You can make it from nuclear and biological processes. You can move it around in pipelines, though you have to have new pipelines. You can liquefy it. You can convert it to ammonia and move the ammonia around, and there are a lot of other strategies. And then we've been focusing primarily in the US on using hydrogen for transportation, but it seems that hydrogen applications outside of transportation may be larger and moving faster, particularly in the iron and steel industry that's been playing a major role in European hydrogen experiments. So with that, I think I have gone from 50,000 feet indeed down to three very specific things that we can that are interesting new opportunities. There are a lot of other ones. That's if you're really talking about getting to zero carbon in 30 years, you've got to do some pretty dramatic and imaginative stuff. And good news is that a lot of those things are emerging. So with that, I will thank you and turn the microphone back to our friend David.
Thanks, Henry. That was a great both overview and drill down into a couple of big areas. And I think folks who are listening in can recognize the scope of this challenge and the many, many pathways and opportunities for industrial policy to have an action. And so now we have Alfred Marcus. Alfred is going to dive down into another dimension of this. Those of you who came in a little bit late, let me just reintroduce him as his slide shows. He's holds the Spencer Chair at the University of Minnesota's Carlson School, and one of his many fields of specialization is the energy industry. So, Professor Marcus, thanks for joining us.
Good morning. It's very nice to be here. I'm going to talk about an implementation paradox. I'm certainly much in favor of electrification personally and at a societal level, and I think it has many merits and benefits. I want to talk about a bottleneck or a sticking point in implementing it, and that's the issue of charging stations. I was very excited, and I think many of you might be as well, yesterday about the announcements in the Wall Street Journal and the New York Times about the Biden administration now thinking about spending $3 trillion, of which some of which will go to charging stations. We know that Henry just talked about it as well. The transportation sector accounts for about more than 25% of total U.S. greenhouse gas emissions. So it's a very, very important part of the climate change issue. And on average, EVs are likely to reduce U.S. greenhouse gas emissions by over 50%. Even the Wall Street Journal admitted that yesterday in a very nice analysis that was done. But it, of course, depends upon conversion of the electric power system into renewables and into nuclear. We're still generating a lot of our electricity through coal and through natural gas, and it really depends locally what the mix is in the emissions of the electric power system as to how much advantage we get from an all-electric system. So there are a lot of obstacles in this ecosystem of conversion to electric vehicles, and I'm not going to look at all of them. I'm not going to look at the battery manufacturers, electricity providers, and so on. I'm going to look at charging stations, just specifically at charging stations, because that creates a lot of anxiety among people and range anxiety. And gasoline, places where you can buy gasoline, gas stations are ubiquitous in the United States, but charging stations still create a lot of anxiety. So if you want to drive across country, this is a map that was in the Wall Street Journal in an article that they had what's missing in the EV revolution, enough places to plug in. And you can see there are large swaths in the middle of the country where charging stations are nearly absent. And even in big states like Texas with large populations, there aren't very many charging stations. It's obvious, you know, this map is a map that is almost a map that you could say is political nature as well. in terms of where the charging stations are found and they're not found. So the Biden administration, their green industrial policy has promised to build 500,000 EV charging stations, and this is supposed to potentially create, and I don't know if these estimates are great, 0.5 million jobs by 2030, and there's jobs in construction, installation, and site development, but there's also equipment design, operations and maintenance, software development, accounting, and customer support jobs. But it's 500,000 charging stations really enough? There's a report by the Brattle Group that said that if we grow, the EVs grow, and this is the big question, how much penetration are we going to get from electric vehicles by 2030? So their estimate is between 10 and 35 million, which is a big difference between 10 and 35 million. But in any event, we're going to need something like not 500,000, but 1 to 2 million public chargers, and that would have the potential to create a lot more jobs than just 500,000 jobs, maybe 1 to 2 million jobs. So how are we going to get there? We have to grow charger numbers by 15 to 30% per year in the next decade, and that's going to require a huge investment. And it's a complicated kind of investment because there are two types of chargers, as we all know. There are level 2 chargers, which take 5 to 6 hours to charge up an electric vehicle. And then there are fast chargers, which might take only 15 to 30 minutes, only 15 to 30 minutes. It's still quite a long time. And we're going to have to increase the number of level 2 chargers. Many of them will be installed in homes, but we're going to also need a 5-time increase in the DC fast chargers as well. So there's a lot of deployment costs, and they're not just the charger hardware, there's the development costs of network design, engineering, and so on. I'm not going to go through this whole slide. And then there's the operation chart costs. And I don't think the costs can be overestimated at all. I'm very familiar with Better Place, the experiment that was carried out in Israel with regard to setting up battery replacement centers, and there was a complete, that company went bankrupt because there was many reasons, but there was an underestimation of how much it was actually going to charge to set up the battery replacement centers. I mean, just to buy the land is a big difficulty, and the estimates are kind of all over the place as to lowest cost and highest costs, and the costs will differ, you know, whether we're talking about slow chargers or fast chargers. And these have not been settled at all, that the cost can be very high. I think that's what we have to take into account. And so the planning for this has to be done very, very carefully. Currently, there aren't a lot of policies in place to encourage it. Even the Biden administration has not come out with specific policies to encourage it. There is a federal tax credit, and then there are rebates, and the utilities in some states are building chargers. But again, it's concentrated in a few states. And then there's the VW gilt money from Dieselgate, the settlement funds that are supposed to be dispensed to create charging infrastructure. And so far, 3 companies have mostly been involved. There's ChargePoint, which has the most chargers in the United States. Tesla has the second most. And you can see that almost all of ChargePoint's chargers are slow chargers. There's more of a mix with Tesla and utility owned, and the Electrify America have barely gotten really started, and other companies have very few going so far. China has far more chargers in the US. A lot of them are fast chargers. And the other thing about China, as we all know, is that EV sales, the sales of electric vehicles in China are also growing much faster and are far greater than in the United States or anywhere in the world. Recently, Europe has really picked it up in comparison to other countries. So the experts that I looked at are saying that we got to do this very, very quickly, and we have to make the investments early. So no matter where you're in the United States, you're able to travel. You don't have that anxiety, where am I going to charge up? So, but the issue of speed and pace is so I want to talk about these bottlenecks or the difficulties of actually implementing this. There are risks of building too many, because there was overbuilding under the 2009 Recovery Act. DOE gave grants to EcoTally of $100 million to construct 10,000 stations, and very quickly EcoTally went bankrupt because there weren't enough people in EVs to charge up, so they couldn't make any money, and there was low usage of the charging stations that they actually built. So there's a kind of a chicken and egg dilemma here. Customers are wary of acquiring their vehicles without the charging options, but the companies can't invest unless there's a sufficient number of vehicles. And the issue is, if you look at these projections about, as I said before, between 10 and 35 million on the road by 2030. But if you look at the projections about ownership, they're really all over the place. And the AEO is the Department of Energy, and they're just taking the historical rate of adoption, and it's very, very low. The penetration level will be 5% by 2030, and EPRI has low and high adoption estimates. I mean, these are just, who knows, what exactly the level is going to be, but it really affects the degree to which chargers can be built economically. So it's not just pace. And so another issue is how. So should we give grants, and should the grants include not just capital expenses, but operating expenses in case enough EVs aren't on the road? So we don't want the existing charging people who own them to go bankrupt, and should we also continue to give rebates? But it doesn't matter. The approval, how quickly they're approved, is also very, very important. The wait time for approval, we don't want corruption. We know that in the past, various government programs for renewable energy, there has been corruption. So we have to kind of balance the bureaucracy versus the corruption issue. And then the other issue is, if we go too fast, we may not benefit from advances in technology. So I talked about slow chargers, fast chargers. There are advances that there's an Israeli company called StoreDot that's working with an energy manufacturer in China that has chargers that have 5-minute charge times. So if ChargePoint built up a network of slow chargers, they may become immediately obsolete and nobody's going to use them. So kind of like matching the technological advances with our need for chargers is another really kind of difficult pacing issue here, and how to actually implement an effective group of policies to make chargers more available to people, and so that they'll buy electric cars. And then there's the issues of standards and standardization. Tesla was willing to make its technology available to everybody, but the other manufacturers didn't want to take on Tesla's technology. So what exists currently is that you can buy an adapter, and with it, if you have a Tesla, you can charge at anybody's other station. But if you have, like I do, I have a Chevy Volt, and I wanted to charge at a Tesla station, I would not be able to charge at a Tesla station because it's on a different standard. So we need a similar standard. That's kind of counterproductive. And then inadequate maintenance. The Electrify America system that has been built up with the VW Gilt money is apparently, there's a report out that it's been very poorly maintained. As many as 20% of the chargers are inoperable, or they work at half speed. So just putting out the chargers out there, if they're not well maintained, it's not going to give people assurance. And then another holdup is the complicated business models, because it's very, very hard to make to make a business. If you or I wanted to get together to build like the equivalent of a gas station, it would take us 20 to 25 years before our initial investment would pay off. So the only good business models are partnerships between a vendor, or a local business like a restaurant trying to attract customers, and the federal government. And if the sole source of a partner's income it's not a viable business model. You have to have these partnerships, and it's very expensive just to connect to the local electrical grid. I said before, this is a very, very expensive business proposition. So establishing these business models is also a great obstacle that may stand in the way of setting up chargers. And I don't think we have a clear type of business model that's actually going to work. So to conclude, I'm all for this happening, and just getting the money out of the system. If there's going to be 3 trillion additional stimulus, and a great part of that, or some part of it, is going to go to build up infrastructure, and some part of the infrastructure is going to build up charging stations, then we still have to work out all these details: the pace of the introduction, the kinds of subsidies, creating common standards, assuring maintenance, and generating adequate business models. So, and a lot of things have to kind of come together for a green industrial policy of this kind to work. We don't want it not to work, because then there will be disappointment, and there'll be people will say it can't happen, and so we need innovation by the private sector. We need incentives from the government, and R&D is part of this as well. We need rebates. We need various programs of subsidies, cost sharing. We need mandates to kind of force it to happen, force deployment. And then we need streamlined bureaucratic processes so that things can happen quickly. But pacing is very important. So that's what I wanted to bring up. And probably you could dig into the electric vehicle sector, into almost any part of it. It's a broad ecosystem. You could look at almost any part of it, and there's similar complications. And there's similar complications. And Henry talked before about push and pull. There's similar complications almost in any part of the system of this vast industrial transformation that we're about to engage in, hopefully as a nation and as a world. And it's important to look at these details. That's my overall message.
Thanks. No, that was really good. And I think no one should underestimate the challenges of doing industrial policy generally and doing it in this context. And with that in mind, we're going to turn it to Sarah Ladislaw, who's the Senior Vice President and Director of the Energy Program at CSIS. We've been thinking about these issues so far, mostly in the domestic context, but there's an international context as well. And that's one of the things that Sarah's work highlights. So thank you for joining us, Sarah. I'm turning it over to you.
Apologies, I couldn't figure out how to unmute myself and share at the same time. So hopefully we're past that technical difficulty. Can you see the slides okay?
Yep, you're good.
Okay, great, perfect. Well, thanks very much for including us in this conversation today. I'm Sarah. I run the Energy Security and Climate Change Program at CSIS. Big fan of David and all his work, so it's always a real pleasure to be part of any discussion he's leading, and this one in particular, because myself and Nico Safos and Lachlan Carey, a couple other people who are on the call today, we're spending a lot of time thinking about both of some of the topics that Henry and Alfie just talked about, but also why it's even more complicated than all that. And so I'm going to walk through very quickly a presentation that is much too long for the time allotted. I put it together to a longer presentation so that you can take it away, but I also want to mention that we do have on our website lots more detail on some of the things that I'm going to present today. So please, I'm going to go through it far too quickly, but there's a lot more information should you find it compelling. So we basically embarked in a project that we're working with the good folks over at Bloomberg NEF on to look at what we, broadly characterize as the coming clean energy competition, and what that means, not just because one, we do need to move much faster if we're going to meet global energy and climate targets. Two, we see industrial strategy as being a big part of how that is likely to happen. And three, we live in a geopolitically complicated world. And so we think all of these things are going to matter a lot in terms of thinking about how this world evolves. And so what we decided to do was embark on a two-phase study. Really, we're the first phase that we've put out recently, industrial policy, trade, and clean energy supply chains, focuses on where we've been. So we've got, phase one is like where have we been and what has happened so far. And phase two is going to be what is the sort of landscape as we see it going forward, and what should policymakers do or think about that. And so, I'll talk very quickly through some of the main points here, but this summary slide basically, captures, solar PV and solar PV, wind, and battery technologies for the purposes of electric vehicles have really gone from being very niche, isolated markets into something at sort of a pre-competitive stage to being cost competitive, to being, in the case of solar PV, global commodities. They've reached a level of maturity and mainstream status that we think is important to sort of ask questions about what did we learn about how they got there, about the government policies that drove them there. Deployment and development of these technologies was very government policy dependent over the course of the history, as you all know very well. And that we largely found that the supply chains and the industries that grew all three of these technologies were very sort of, isolated geographically, and then they grew into these global supply chains. And then these global supply chains have come to be dominated by China in terms of manufacturing capacity. As you'll see, this is more true for solar and less so for batteries and wind for specific reasons. We want to make a point that there is this overarching narrative that we grew these markets by linking different countries with different supportive policies, whether on the supply and the demand side, and this is by and large true. But it wasn't exactly as if we were operating in a free market condition. There was always, because of the nature of subsidies and tariff barriers, there was always trade disputes throughout the history of the growth of these markets, but they tended just to sort of, yes, they did damage to some, domestic industries, but they also just tended to reorient supply chains to new countries to try and circumvent some of the trade barriers that we saw. We'll talk a little bit more about where we think that might be headed. And finally, in this study, we looked in depth at the development of solar PV and wind and EV battery manufacturing as just sort of, as those supply chains have evolved. But we also looked at different case studies looking at China, Germany, and India to try and evaluate, what was it that they tried to do to grow markets for these technologies, to protect these technologies so that they could grow manufacturing capacity. And is there anything that we can learn? We hear all the time that we want to, have a clean energy economy that includes jobs and manufacturing and domestic economic benefits. So what do we know about how countries have tried to do that in the past? And is there anything that we can learn from that experience? So this basically just summarizes the huge amount of growth that we've seen, not just in solar power generation capacity, wind, and EVs, but also that just the trade in these goods, for example, trade flows and clean energy exports have really reached in a trade sense something on par with what we've seen in markets like liquefied natural gas, and so they're not sort of these niche markets anymore. They're globally traded goods and of some consequence. They still do, though, which is really important to point for our second part of the study. They still represent relatively small shares of their overall power sector or vehicle deployment sector, but they're anticipated to grow, and not just if we meet our global climate targets, just on the cost competitiveness of them alone, according to Bloomberg NEF, they've got a lot of market potential. So again, I don't want to belabor all of these issues, but this is just looking at the worldwide installed wind and solar power generation capacity over the study period that we were looking at it, and really showing, one, the magnitude of growth, but, obviously the major role that China plays in a third of the total installed capacity for wind and solar, compared to about a fifth for the United States, and then a wider spread for countries around Europe and elsewhere. This similarly looks at the growth in EV electric sales. China's been the largest EV market since 2015 and has over half of the total annual sales in 2018 and 2019. Just really kind of showing their dominance in the sales portion of that market. And then this shows the cumulative installed capacity going forward. This is what we expect to see in the US. Again, this is just making the point that according to Bloomberg NEF, and this is not, taking into account what the, Biden administration might put in place in terms of policy or regulation, just a huge amount of growth for solar and wind, expected to make about 56% in 2050 of our US installed power generation capacity. And there's just huge amounts of investment figures that go into making that outlook possible. And then also, EVs are more sort of nascent in terms of, just reaching their point where they might be cost competitive, but Bloomberg NEF sees a bright future for EV deployment in the United States as well. So what do? We all know the market is likely to grow, and if we have these clean energy policies, it'll grow much faster. What are some of the points about that for US policymakers? Well, a couple things we wanted to point out. We have 3 slides that I put together that our Bloomberg NEF colleagues put together on, how do you think about how value accrues to the United States when it comes to the solar PV or the wind or the battery EV batteries that are manufactured in the United States. And, by and large, in the solar market, solar PV is much more commoditized. It's the competition, in terms of keeping prices low is it's much tighter. You've seen lots and lots of companies go out of business, for manufacturing solar PV, not just in the United States, but in China as well. But one of the things that was clearly came through their solar their supply chain analysis is that China does clearly dominate in solar PV, both in even if it's assembled on U.S. soil, as you see here, 60% of the value in the materials upstream in that solar PV go to China, and even if you buy a solar PV from outside China through Southeast Asia, many of these companies are Chinese companies. A lot of that value accrues to China. And again, we're not making like a value laden point here. It's just essentially that China has done a lot to, create this position for itself, and therefore it just has sort of an overall level of dominance in the supply chain for solar PV. The situation is different for wind. Because it's not quite as commoditized, it's still specialized. Performance really matters, particularly as we're innovating on the size of these turbines. There's a lot more sort of hubs for manufacturing for wind turbines, and there's a lot about wind turbines that makes it harder to sort of trade them across borders, particularly given their size. And so the point here is that when you look at sort of a typical wind turbine installed in the U.S., there's a good amount of value accrued to the U.S. For wind turbine manufacturing. The point on on electric vehicles is a little bit more nuanced. There's a lot of growth and development that is expected to take place in the market for battery electric vehicles. This slide compares sort of two different manufacturing plants in the United States, and basically shows that it's a complicated story. Obviously, one of them is a Tesla Panasonic partnership, where some of the value is accrued to the United States, some of it to Japan. Whereas in the Korean battery manufacturer case, a lot more of the value is accrued to Korea in this case, but also a bunch in the United States because of its position in the United States. The phenomenon that Bloomberg NEF sort of pointed out in this analysis was that there's a lot of clustering that happens when it comes to the growth of the EV market. So they've seen a lot of clustering in battery manufacturing and car manufacturing in China, in Europe, and expect to see the same in the United States as the market for batteries grows. So I'm conscious of time. We went through case studies in this first report, and by and large, just to summarize some of them, one of them was on the case for EV development and deployment in China. And over the course of the history of development of the EV market in China, they wanted to do two things. One, they wanted to grow the market and change their vehicle stock at home, but they also wanted to grow into an export market. They've not necessarily been as successful in achieving that goal of being an export market, but they sure as heck made themselves able to, through a whole bunch of subsidies and targets and incentives, grew a industry for themselves in being the deployers of EVs that are largely purchased in the Chinese market. And so when we looked at a couple of the two other case studies, just moving on to India and Germany for a second, the thing that stood out for us in China is that they did effectively and quite aggressively use both sort of demand and supply side subsidies, and really quite, stayed at it in terms of trying to develop and grow that market and develop and grow their manufacturing capacity in that market. We saw two different kinds of cases, one in India, one in Germany. India in the case of their national solar mission, where they were really trying to grow a domestic market for a domestic manufacturing capacity for solar PV to support some of their very lofty solar targets. They did this through, trying to mandate 30% local content. There was a lot of loopholes. There was the WTO case that the U.S. was eventually victorious in, and they successfully grew a little bit of manufacturing capacity, but they're largely still very dependent on importing solar PV from, in particular China, which was, one of the targets for the reason why they were putting in some of that, the supports for domestic manufacturing capacity. On the other hand, Germany, put in a very notable feed-in tariff that tried to grow, made them into a very large solar PV market. And at the time, they were actually not only the largest PV market when they put that into place, but then also they manufactured a lot of the solar PV as well. Over time, they just didn't compete in that way. And therefore, they did a lot to grow their own market. They did a lot to grow the global market through the aggressive demand side subsidies that they put in place. But at the end of the day, didn't necessarily grow sort of domestic manufacturing capacity. What are we supposed to take from all of this? There's no one right way to do industrial strategy. What we noticed, though, is that there's a lot of different countries that have different reasons why they're doing things, right? Some are for environmental reasons, some are for industrial competitiveness reasons. Even in the case of China, which looking across these three countries and looking at the experience of the United States, in fact, probably is arguably the most successful in terms of growing a market for these technologies and also supplying the goods and the technologies for that market. It was pretty inefficient and it was really expensive. And so it's hard to foresee that other countries would be able to do what China did at the rate and pace and scale of what they did. So just to move along really quickly, and I won't be able to clear through all this because I do want to make sure we've got time for discussion. We have a phase 2 part of this study. Really what we were doing in the first phase was sort of looking back at how we got where we are and trying to discern some lessons from that. The phase 2 study basically looks forward and says, listen, if we're about to embark on, rapidly reducing greenhouse gas emissions on the scale that, global targets say, we're actually, to Alfie's point, we're going to be moving at a rate and a pace that's really fast. And so we want to understand what that's going to look like and what that will do, not only to these more mature existing supply chains, but to these new supply chains that we're going to be cultivating over time. And so we see a number of different things that are important to consider. Industrial policy doesn't just come from the desire to drive technologies into the market. It also comes from some of the economic considerations, trade, national security considerations that we've seen drive, say, oil and natural gas policy in this country for a very long period of time. And so we started to bring some of those dimensions in and basically, a few different things. One, we know that in order to reach deep decarbonization, this is not just about dropping the cost of renewable energy technology quickly when it comes to power generation technology. We sort of know how to do that. We're going to keep doing that. It's about integrating these technologies into the system more broadly and about decarbonizing the sectors that are really hard to decarbonize, which I think Henry was talking about earlier. We understand that there's the policies that a lot of countries are putting into place to be able to do these types of technologies are largely more protectionist or more interested in sort of taking some of the domestic, the economic benefit that comes from this transformation and making sure that that stays at home, which is politically understandable. It's just not, how we from a techno-economic perspective have looked at this issue for the last 15 years or so. If you also look at the trade environment, you look at the history of clean energy technology and what it's taken to support these technologies and the incidence of trade skirmishes that we've had for a variety of different reasons. And you look at the rate and pace and scale that we're going to try and move going forward. It's not, crazy to assume that we're going to see additional trade skirmishes over these types of subsidies and supports. And so we think not only just the overarching tension that we're seeing in global trade realms anyway, but also the sort of strategic nature and the real investment that's going to go into these technologies, as we think that trade, those trade tensions are going to grow. And then the one of the final points is we really think that in some of these we've seen on the national security front some of the concerns over these technologies. If you think about a deeply decarbonized energy system, that there's a lot more distributed energy resources. Most of those energy resources are connected through smarter systems. Smarter systems mean more vulnerability, and we've started to see more concern within the national security community about the supply chain and how vulnerable our supply chains are to disruptions of all sorts, but two, on sort of just on the electric power side, how much of that equipment is actually susceptible to nefarious intent from other actors. In particular, we saw this in the Trump administration had an executive order that was looking at trying to get software out of the electric power system that might come from other countries that we don't trust, right? So I want to race a bit to the end here. We're basically going through looking at this landscape of potential threats coming from one, growing industrial policy, two, growing trade tension, and three, this national security realm, and asking questions about what policymakers are going to do to deal with and confront those issues as they try to enact more policy that moves us faster down this realm of industrial policy. And I'll just I included lots of other slides so you can see some of the substantiation that we've done of some of these different trends. But if you go to the end, we see there's a number of different policies that governments are going to deploy in addition to these sector-specific policies that we've talked about. One, we've already seen discussion from the administration on focusing on supply chain resilience, right? How do you make sure that your supply chains for goods that you think are going to be strategically important are in fact resilient? Two, domestic governance. Do we need to build different, stocks and supplies and redundancy for and mandate those in the way that we've done with, like, say, a strategic petroleum reserve? Making sure international institutions are paying attention to this. We've got a paper coming out about how the G20 and the WTO should probably be adjusting. Diplomacy and force projection. This is a little bit more from the international affairs side of the house, but we have an entire military and defense structure that is predicated on the way that we were using energy resources. Are we going to need to think about having one that is predicated on the way we're going to use energy resources? We think it's really important. You're not going to kick China out of these supply chains. If you don't want China out of these supply chains, you want them to grow as well. How do we create complex interdependencies between the United States and China and other countries to make sure that we're all acting in the same shared interests as opposed to fighting vis-a-vis one another? Regional diversification, you're hearing about supply chain alliances, people talking about how do we make sure that this doesn't, become a system of supply chains where we're reliant on one country for all of the resources and technology that we need. Fuel diversification, again, thinking about that in the context of a low carbon future is just as important as it was before. And then finally, one of the things we want to make crystal clear is because we looked at, technologies that have become sort of more conventional technologies, we think a huge amount of this industrial competition is actually going to take place in the technologies of the future. And so trying to put our sort of strategic brains and our industrial strategy brains around not just technologies that we're developing that we have today, but the ones we're developing for tomorrow, and understanding how innovation can actually help alleviate some of these concerns is also an area where we see a lot of opportunity for strategy. So sorry for going long, but that's what we're working on.
Thanks, Sarah. So a lot of material really fast. There's more to be found on all of the speakers' websites and in their publications. And let me just thank them for sharing their thoughts with us today. So we're going to move into some discussion. I think we'll go to 120 before we go to the breakout. So those of you who would like to have a more intimate conversation, we have some time for that. Beginning around 1:20, and we have a pretty active chat, but please drop questions into that. I can't promise that we'll get to all of them. So let me begin though with a question about the United States, and I'll ask each of the speakers to reply briefly to this. So Sarah, I was glad you brought up oil and gas. Many people in this session know that industrial policy, of course, has always been with us. We just have denied that it was there, but oil and gas sector is a perfectly good example. But if you have to think about the US has sort of one strength and one weakness in carrying out industrial policy in these areas, or carrying out an industrial strategy, if you prefer that term. What would you point to? And let me put Henry on the spot first. So, what is the US, good at and bad at? And then maybe we can circle back and talk about where that leaves us.
Well, I guess that our main strength is that we have a fantastic university research complex and national laboratory complex and other corporate research infrastructure for research that is really unrivaled. And there are many crucial areas, information technology, biotechnology, and other areas where we're clearly world leaders. Where we're stumbling is our ability to put together national programs that translate these innovations into manufacturing products, scaling things up, demonstrating things, creating integrated industrial policy. So I would say that that's our major weakness, and I'm really hoping that this Build Back Better initiative of the president is going to help solve that.
Thanks, Alfie. What are your thoughts on the U.S. as a competitor in these sectors?
Well, compared to China, the dominance of China is an amazing fact, and I think that going in line with what Henry just said, that it's very, very important to think about how the private and public sectors have to collaborate and creating partnerships of various kinds. I once worked essentially in a national lab, and the national labs are quite isolated. In my view, I mean, in the 1970s, we were having the same problem of nothing ever gets commercialized. I don't think that's entirely true, but there is the disconnect, the push-pull disconnect. And it seems that China, when they pull strings, the strings get acted upon, and we don't really have the mechanisms in place to make that happen quickly.
Thanks, Sarah. How do you think about the US's strengths and weaknesses coming into this?
Yeah, it's a great question. I tend to think we're just too, we're really afraid of failure, and we're really afraid of like picking a priority, because it got this picking winners reputation. And I actually think that you can have it both ways, right? I mean, you can have, this is why climate change is actually really helpful, because it kind of gives you a prioritization structure within which to, measure your industrial strategy. I just think that we're just not very agile in terms of our policymaking structure. So we have one failure and everybody kind of like goes home for a long time. I mean, my biggest example of this is biofuels. Like, our biofuels policy is nuts. And it's nuts because nobody can fix it. And it's been nuts for a long time, and everybody knows it's nuts, but nobody can fix it. And like, that's a hard environment to be agile and adaptable to the kind of things that we need to do. So I do worry that we've got this like fear of failure that's really unhealthy, that I actually just don't think is as big a problem as it's made out to be, if we were able to adjust policy a little bit more easily.
Could I just follow up a little bit on that? Is this reflecting some underlying, flaw? I mean, I think in the case of biofuels, it seems like it has to do with the way our congressional system is set up in our presidential primary system, right? So Iowa is first, and so therefore, those corn farmers have their say. Because if it does reflect that some kind of underlying thing, it really seems really hard to fix that. Or how can it be fixed?
It does, but I mean, I think we're actually at this really interesting point, and this will be something, for the Biden administration to test in a number of levels. Like, for a long time, our discussion about deep decarbonization has been a techno-economic one, where we sort of solve for an equation and sort of reduce cost and figure out how to scale, and that's the answer to the question. But a lot of our politics is broken because we have regulatory and firm capture in our political system, which is not super helpful for, adjusting to an entirely different system. And so I actually think if you're able to have examples at the local level of new types of innovation, which you're seeing, right? I mean, I think Henry brought up, even the Trump administration was trying to zero out R&D dollars for clean energy, and they couldn't do it because guess what? States like it. It's beneficial to them now. If you can change the politics around this issue because of the deployment of different clean energy opportunities at a much more local level, I think you can unearth some of those, you can turn back some of those challenges that have been, troubling over the last couple of decades.
Thanks. So I want to take just a brief break here and recognize Liz Reynolds and say congratulations to Liz. Liz was recently appointed as a special assistant to the president for manufacturing and economic development, I believe. So Liz has been the spearhead for ISA's conference, now twice virtualized. We were supposed to be hosted by her at MIT. And so on behalf of ISA, I would just say thank you for all that work that went into those conferences that is still being partially realized. And also, congratulations and good luck, right? I'm not even sure we could say from the frying pan into the fire, a little frying pan into a big fire, but Liz, thanks. She assured me she wouldn't speak on behalf of the administration today, but I do want to, give her a chance to say a word or two.
Okay, thanks, David. It's great to be able to join. Sorry, I'm late. I'm not speaking on behalf of the administration because I technically am not working for the administration yet. I start in a week on April 1st. But I mean, as obvious to everyone, this is going to be a major part of the new administration's agenda, and I really appreciate those comments just recently, which spoke about the important role of sort of regional ecosystems and regional models of innovation. That's certainly been my background and working in manufacturing and elsewhere, and so I'm a big proponent of driving innovation from the regional perspective. So I appreciate that and hope that's part of the agenda going forward. But look forward to being in touch with this community and helping move this forward in any way that I can. I also would say I completely agree with, the story here is not just about money. It is really about policy, programs, tools, and how we bring those into the 21st century as well.
Liz, thanks a lot. We appreciate that. So maybe we could just pick up on the point about regionalism and how that fits in. So Sarah mentioned, I think, clusters. Maybe we start with Alfie. So Alfie had some maps and kind of intrinsically the transportation system has some regional aspects. And how does our federal system, would you say, kind of fit into the industrial policy landscape? Alfred, go ahead.
Well, we once built a national highway system and it's oftentimes that we do amazing things like the emergency relief effort that we're seeing right now is really changing welfare policy in amazing ways. Maybe it'll become permanent, but we do it for strange reasons. Maybe we have to create something of a national campaign around the fact that we're going to lose this race to the Chinese and make it into something like that. But there are huge differences right now, even in the gains that can be made from electrification that depend heavily upon the degree to which localities or regions are more renewable in their nature. So if somehow we can think about this in more systematic ways where there are subsidies given at the same time to become for renewable energy, for chargers, for electrification, for system-wide subsidies rather than piecemeal subsidies at a regional level, being sensitive to the differences among regions, I think that would be a way of moving forward.
Thanks.
If I could chime in a bit on this regional issue, there are several connections here between these talks that bear on this. One is if Alfie succeeds and electrifies the transportation system, you've basically eliminated gasoline and in the process eliminated ethanol, which is 40% of the corn crop, which is most of Iowa. So I think that in spite of the fact that there are a lot of conservative incumbents here, there's going to be a real interest in innovative ways of dealing with this new transportation infrastructure that's not based on conventional fuels. And there are a lot of very interesting opportunities for doing that, including finding ways of getting a competitive renewable fuel. Secondly, on the question of charging infrastructure, it's been observed that electric cars are still cars, and they still create congestion, and they still make cities miserable. And these cities are moving very rapidly to try to find ways of getting individual cars off the road. And the shared mobility, the charging infrastructure for a shared mobility model is quite different than the charging infrastructure for everybody driving alone in their car. So I think each region is going to have to deal with it separately, but there are a lot of interesting new dimensions that are being introduced into this discussion.
Right, so that for charging stations, the real people who are going to own and run them are going to be the mobility companies rather than individuals, and that's a different business model.
Yeah, I would say that approaching things from a systems perspective is one of the challenges of our system, and it may be true in any system. Mature political economic systems always have these legacies built into them. Well, let me pick up Cynthia Kroll's question and direct it to Sarah, because I think it speaks to her point, how to balance cooperation and competition as we move into this new world. Obviously, the meetings between John Kerry and his Chinese counterpart are starting to bring this into perspective for us, immediately. How do you think about that cooperation and competition question?
Yeah, this is something, and noticing my colleague Nico Safos on the line as well. I mean, we've written about this topic. I mean, I think it's tricky, but the golden opportunity here is to create productive competition, right? So there are very few things that China wants to be known about on a global stage, and wants sort of like, actively seeks out positive reputational, feedback, and also sees economic opportunity, and that's climate change. And so I do think we have to figure out a way that we construct international cooperation that tries to get us all to be trying to outcompete each other, right? And so some of that has to do with how do we deal with standards? How do we think about supply chains? How do we think about some of these collaborative organizations that we have, whether it's the G20 or the WTO or the UNFCCC or the SEM or Mission Innovation? How do we use that, international architecture to try and put guardrails on, what we're doing so that it doesn't become, again, sort of this race to the bottom? The report that we had put out was called Race to the Top. And to be honest with you, I think the most important thing to do is the US has to try really hard, right? I mean, if the US was actually investing a lot of money and trying really hard to do this, and our allies felt like that was a direction they could count on for a period of time, right? And we could structure, science and technology collaboration, deployment collaborations, because again, we're going to try to do this faster than the market allows for. So some level of artificial collaboration in industry is going to be necessary. And if we could start to really lean into those collaborative efforts, I think that there's a lot that we could do. But let others comment.
A bit of a paradox there, if I could just go one step further, which is it seems like one of the ways that the US can try harder is by pumping up the China threat. So there's a little bit of it, seems to me, a built-in paradox. So if we can't try harder unless we're afraid of someone else, and yet at the same time we want to maintain some guardrails.
Yeah, and I think that's those are the guardrails to protect on our side, right? Which is we have this tendency in geopolitical terms to worry about whack-a-mole, right? Not everything China does is bad. There's some stuff they do that is good, and we should encourage them to do the good things, and we should co-opt them to not trick them, but we should certainly co-opt them to do more of the good things, and only have fights with them on the bad. And so I think that the Biden administration instincts to try and figure out how to keep that global productive gain cordoned off from the other tit for tat pieces between the US and China is going to be really important. But at the same time, you can't be Pollyannish, right? If you think that Chinese infrastructure is a national security threat in your critical infrastructure, you don't get to ignore that, right? You don't get to pretend that's not a problem. You have to deal with it in a smart way. And so there's going to be lots and lots of areas where I think we have to deconflict on some of those things.
Alfie, did you want to jump in on this?
Well, maybe not. I think it's very important also for us to have a consistent policy where it's possible for the private sector to invest with less uncertainty. So that what typically, I think what's happened in the past is that there'll be a setback, there'll be a fumble like the Solyndra issue, which one could speak about. And then there's kind of a backlash, this doesn't work, it's corrupt, the government involvement, there's a kind of ideological backlash. And I think we have to say, we're going to do this, and these are our goals, and we're going to stick to them. And that creates an environment where the private sector, it's easier for the private sector to invest, to have plans, to know that these policies are going to be around. Like every time we do the rebates for wind or solar, you know, there's all this uncertainty. Is this Congress going to come along or not going to come along? It's hard in our system politically to do it, but I think we need something that's longer range and consistent, that creates an environment of certainty.
So we'll do like one more lightning round here, and then we'll move to the breakout groups for those who want to join. And we'll start with Henry. So optimistic, pessimistic, and why? I'll let you interpret that.
About
Question.
Well, I think that I'm certainly optimistic that the technical solutions to meet these ambitious climate goals are at hand, can be developed. Pessimistic that we can have the political stability that Alfie is talking about to be consistent in our approach. And I guess since Sarah's going to answer this too, you know, one of the big troubles with the loan guarantee program, I think, is that it had a 95% success rate or something like that. That's absurd. That's higher than a bank's success rate. It should be much lower than the private. But, you know, how do we end up actually taking risks with public money and not getting trashed for it?
Alfie, how feeling now that you've dove deeply into one of these sectors?
I'm too old, so I've seen too much. But you know, I think that the issue is not a technical or scientific issue, although the science and the technology is not going to be developed in an even way, and it's going to be advances that are going to throw open everything. But I think the major issues here are on the policy political side, and there are going to be in every area. It's a very complex system, and in every area there are going to be bottlenecks that were unanticipated that are going to affect the entire system, and it's impossible to really anticipate all of these beforehand. So I leave it to younger people like Sarah to figure all this out and get it done. And I'm still hopeful. I mean, I think ultimately there is going to be a huge transformation in the way we live, because I've already seen it in my lifetime, and it does happen, and it will happen in this space.
Sarah, we'll give you the last thought.
Well, my last thought is I always want to be on panels with Alfie because he calls me young, and that's nice. Thank you. So I'm really positive about and optimistic about this, and partially because, you know, like when I started doing this a long time ago, it struck me that all we needed was enough. Like, this is just a weight issue, right? If there's this thing called the opportunity tipping point, and if there's more people that believe that the economic future is headed in that direction than in that direction, right, in terms of low carbon, then like you can create a lot of critical mass, you know, heading towards a low carbon system. So I actually think we can make a tremendous amount of progress in the next 10 years, just based on the sheer excitement that we've like actually reached this maturity level for a huge amount of what is going to decarbonize the electric power system. That optimism, if it bears fruit, can spill over into these other sectors where we need doses of optimism. We may still fall short of our climate targets, but I do feel very positive about our ability to make real progress over the next decade and sort of stay in the game, so to speak.
Can I say one more thing, just very, very quickly? I think that the financial system of the United States. Money, big money, is behind this now in a way it's never been behind before. And the more it gets entangled in it, becomes committed to it, it's the harder it's gonna be for us to move out, because that big money is going to also put pressure on government to stay the course. And I think there's been an enormous change. And if you look at, the big investment houses, they see opportunity now, and they have a social conscience of some kind that I think was not there 10, 15 years ago.
So thanks. It's always good to end a climate panel on an upbeat note. It's not that common. So let me thank the speakers for doing that and for sharing their wisdom with us, and thank the participants. A lot of great stuff in the chat. I'm sorry I wasn't able to get to it. It's, as always the case with the webinar format. And let me invite folks to join the breakout groups. Stephanie will do her magic. So stand up, stretch your legs, give it a minute, and then please join us. We'll run those until about 2 o'clock for people who are interested in. It's going to be random assignment, but I think you'll have a speaker or a colleague of a speaker in one of your rooms wherever you land. And again, thanks for joining us. Please join us again April 7th for the session on the racial wealth gap. And then we continue the industrial policy series April 28th, I believe, with a session on federal agencies. So thanks again. We'll close the plenary portion now and adjourn to breakout groups.